Yo, everybody. It's time for the ham radio crash course. How is it going Friday? It's always good. It's always a sign of a very excited. I'm always very, very excited for Fridays, and it's always a good day whenever we got the crash course going. So, we'll get going in a second here. I'm going to get some stuff going on. I got to type some notes. Make sure I do that first. Don't forget that, too. Let everybody get a chance to find some seating down in front. People already jumping in. Awesome. The chat's already blowing up. Thanks everybody for hanging in there. Even the APRS messages were blowing up. Had I think I got like 3 or 4 messages before the stream, just going back and forth. Super cool. Super cool. Hello from Cincinnati. What's up? Yeah, the bands are pretty open right now. 20 meters, 40 meters, pretty open. Pretty cool out there. Time to get on the RF waves. And how do we get on the RF waves? That's what we're talking about today. We're talking about propagation. It's all about propagation for today. And of course, my radio is still having that problem. I fight these Logitech. I fight these Logitech cameras a lot. Anyway, we're fair to good on 20, and we're good on 40/80, which is pretty cool indeed. Okay, so, oh yeah, let's talk about propagation. So we're hitting propagation today. So it's pretty interesting. We've been kind of leading up to this. Last week we talked about antennas. I hope you enjoyed that. I had a lot of fun with the antennas video. And now we're talking about propagation, which is kind of like the capstone of all the stuff we've been talking about. So we'll hit that in a second. I got to do my normal housekeeping stuff. Want to make sure everybody knows that we're moving forward with radio. That's why we do this. We try to add a little bit of knowledge to our repertoire and then practice it. Get out there, practice. You can see that that's going on from the Facebook group. Lots of people posting pictures of their ham shack. Lots of people getting out there and working on stuff. Literally going outside and doing radio, which is awesome. We have Field Day coming up. Field Day is a huge thing. There's a poll in the cards, so make sure you go check that out, answer that question there. I will be talking about Muff. We'll be talking about Muff and the Luff. So, spoiler alert for anybody looking for information about the Muff, which in RF terms is what we're talking about, of course. Ham Radio Crash Course again is on Facebook. We've got a Reddit. We opened up a Reddit. There's a link to the Reddit on the Facebook page. If you search for Ham Radio Crash Course on Reddit, you will find the Reddit, which is awesome because there's a lot of people who... Whoa, that was an interesting beep. There's a lot of people who don't want to do... Well, that's somebody's repeater. There's a lot of people who don't want to do Facebook. They just want to do something else. So that's why we've got the Reddit. Let's see. Next stream. So next week's going to be pretty crazy because obviously we have Field Day, but the stream happens before Field Day. So next week's stream is going to be kind of a Q&A, just a fun stream. We're going to try and make some contacts. I'm probably going to be working in the backyard from the laptop that I will be streaming on for Field Day, kind of shaking out all the bugs and stuff like that. So that's just going to be a lot of fun. If you have questions, stuff that's been bothering you, or you want to get a contact, try and work a contact before Field Day, or you know, shake some stuff out, we can try and make that happen. So I'm excited about that. Okay, what else? Dakota Lithium batteries, which I had it with me, but I went to go charge it. Come here, buddy. We had a problem with the coupon. It has been fixed. So this is your last chance to get the battery before Field Day. DakotaLithiumBattery.com. For those of you that are interested, there's a coupon if you use the word Hoshnasi. And I believe it is lowercase HOSHNASI. Okay, cool. Let's see, what else? I want to make sure I don't forget a thing. Oh, let me go back. So I'm starting to take meme pictures that people put together. This came from Discord by N. Shane, made on a fang and a prayer, which is pretty funny. The last one was... I'll have to look up who made that, but very cool all around. Appreciate the funny memes that's coming out on the Discord. Okay, without further ado, it's time to open that beer. I got a good one today. The Brew Rebellion, The Dead Man Walking, a Vietnamese coffee milk stout. So I don't know if you guys have had a Vietnamese coffee, Cafe Sudad, or Sudad? Cafe Sudad. I'll have to ask my wife. She speaks Vietnamese. Anyway, it's one of my favorite coffee-type beverages. Oh, good, Zach. I didn't even have to ask. Thank you so much for posting the link to the Discord. And the Discord is where we will be doing our after chat. Should be a good one today as well because I got plenty of time to do it because everybody is out of the house. Here we go. Got my San Mig cup. Ooh, that is dark. Darkness. All right. Very good. Café Soda is a strong coffee drink that has chicory in it. And they use this very interesting filtration system that they slowly, very slowly draw the coffee out. And they add it to the top of condensed milk. And then you stir it up. Man, Vietnamese coffee is delicious. And it's often served over rice. If you can get it as traditionally as possible, I totally recommend it. Café Soda or Vietnamese coffee. Very good. Let's try it. Jortron. There's a YouTube channel called JonTron. Big fan of JonTron. I got really excited for a second. I was like, is that JonTron? Jortron, you and your app helped me pass my test. Missed one question. Heck yeah. I'm assuming that's technician. Awesome either way. Super excited about that. Very, very cool. They quit making Sam Mig. Did they really? I didn't know that. I haven't had a Sam Mig in probably 5+ years. This is good stuff. And I've got a hint of that chicory taste in there. And it tastes like a milk stout. Carbonated milk stout. So it's not nitro, right? It's got a sweet mouthfeel because it's milk stout, because it uses lactose as the sweetener instead of fructose. Okay, cool. All right, so I hinted it. We've been talking about it. We've been building up to propagation, okay? Everything to this point we talked about. We went real low level, started talking about the components of the radio, parts of the radio, what they're used for. We talked about antennas last week, and now we're talking about propagation. The unity, the circle is complete after we discuss propagation. If you've ever wondered why people say, oh, this band is better at night, or hey, we're in a 11-year low, or we're in a solar minimum, we're going to explain that today. The sun is why we can use HF radio the way we use HF radio. It's why we can basically bounce. The word is refract RF over the very outer edges of our atmosphere and send it back into Earth. Without the sun, none of that would be possible. I think VHF, UHF would be possible, but I'm not sure about that, and this book doesn't mention it, and that's okay. I will give kudos to the ARRL book for taking a very linear approach to this, starting out with the components, the simple components of electricity, and working your way up until you get to the more heady stuff of how antennas and now propagation works. This is a fairly short chapter, and there's not a lot of questions, so we should be able to get through this pretty easily. So I'll just say this up front. If you are thinking about questions or anything like that, go ahead and start thinking about them now. Maybe write them down, get them all queued up. Maybe wait a little bit on the chat room, or as always, you can throw me a super chat, and that'll go right to the top. Oh, somebody asked me, how can they support the channel and not necessarily use Patreon, not necessarily use super chat? Totally cool, I understand. No problem, no pressure. Use Amazon. If you shop at Amazon, please use the link. It's at the bottom. It's in the description. No more cost to you. It just gives me a little taste of the action. And we're talking a % or 2 here or there on your purchases. So that's how that works. I'd appreciate it. Helps the channel go forward. All right. Okay, so what happens is the UV from the sun goes and hits the particles that make up the very loose particles of our ionosphere. The ionosphere kind of tops out at, what's it say, 30 miles of height above the Earth, okay? The ISS, the International Space Station, is 20-something. It mentions that too. So the ionosphere is pretty high, right? It's pretty high. It goes past low Earth orbit kind of thing. So the UV, whether it's daytime, the sun is facing the ionosphere, the affected area of the ionosphere or not, the UV light is going to ionize the particles that is loosely made up of the ionosphere. And it's going to make the atoms basically have a positively charged ion and a free electron. Now, based on the density of those particles, and I know I'm getting a little heady, it's not going to be a ton of science past this point, but you got to understand this. Basically what's happening is it's creating like a conductive field. And it just so happens that that conductive field responds and refracts RF. So if it wasn't for the sun and the UV light, we would not be able to have these ionized charged particles, and we would not be able to communicate. We would not be able to use HF to refract our RF. Okay? What's up, Todd Riddle? Thanks for kicking it with me. I appreciate that. So that's what this is all about. Where the sun is during the day, where the sun is facing the earth, how that affects the different bands you're functioning, all of that is in play. All of that is in the area of propagation. So let's flip the page here, because this is basically covered by this next awesome, oh, see, look at that. I left the, let me do something real quick so I don't forget this later when we go to do our, come on, buddy. There. Sorry. Got to make sure I put this thing on airplane mode, and I always forget to do it. Okay. So here's a really good picture of all the different layers. There's D, there's E, and then there's F. And depending on if it's sun-faced or not, F1 and F2. When you're on the dark side, when the sun is blocked by the earth, you lose D, E, and F1 and F2 just become the same thing. Okay? Right there. Yeah, Carrie says don't forget to click the like button. Yeah, I would love it if you click the like button. That would help me out a lot. Thank you for doing that. Here's an interesting vertical view, right? Stratosphere, and then you got the D layer, the E layer, the F layer, and then the F2 layer. Now, when we talk about HF, particularly in the evening, and how we talk about how certain bands are better in the evening or whatever, that's this effect right here, this basically blanketing of this whole area. Because what happens is the D and the E, they can, because it's more densely packed, it can absorb some of that RF. But when you get the sun out of the way, it disappears, and you get this nice open area that you can refract RF off of. Did the stream end? Oh, I hope nobody's having problems. Biker Bob, what's up? Thanks for coming in here. Oh man, we almost had a beer catastrophe. I had a charging cable wrapped around the stem of this glass. All right, so hope that makes sense. It is fairly scientific, but it's very common sense. We have the further you get away, the density of these particles spreads out, and the less dense, the less it absorbs RF, and the more it's affected by UV light, right? Because the sun is coming into the much looser aligned particles, and it's creating that reactive, conductive mass that RF can bounce off of. Thank you. Cool. All right. So I've kind of already mentioned it. Reflection and absorption. I'm going to read some of this stuff because it does get a little sciencey, but again, this is all fairly straightforward stuff. Reflection is really refraction. You can think of it like a mirror, this imaginary mirror. If there was no mirror, this RF from your station would just fly right out of the ionosphere. It doesn't, though, because you have this mirror effect. It's really not. It's a actual path of this bending of light, if you will, a refraction. Okay? So the higher the region's ionization, we already mentioned that, the more the wave will be bent, right? And the closer you are to the UV light, the more ionization there will be, even though the density is less, but less density means it will absorb less, right? The higher the frequency of the wave, the less it is bent. This is important. In fact, at VHF and UHF, the waves are hardly bent at all and are usually lost in space. There is a reason why we use VHF and UHF in satellite communications. And a lot of it is so we don't get this weird refraction and bending of the RF. We want it to go as straight as possible when we're trying to talk to even a low Earth orbit satellite. That's one of the reasons. VHF has that. That's a good thing. That's a feature, if you will. Okay. So some combinations of frequency and ionization levels will result in weak bending. In these cases, the waves must leave the Earth. So if you have a vertical antenna or a dipole antenna, which we talked about last week, there's a trajectory that the RF comes out of that antenna. And it's as you've seen in those antenna plots. Remember, there are vertical and horizontal antenna plots. And in this case, we're talking about the horizontal plot. So if you had a vertical, you'd have some kind of lobes of emission of RF information, right? Well, the angles that RF comes out is your takeoff angle from your antenna. And depending on the frequency you're using and the takeoff angle, it could hit the atmosphere at a point in which it wasn't enough angle or too much angle, and it could actually fly through the layer, the ionosphere, or if it's at the right angle, could bend and then refract back down. So that angle is called the critical angle and depends on both the ionosphere, the conditions of the ionosphere, and what frequency you're operating on. And that's going to become immediately apparent when I flip the page here. Okay. In the D and E region, which we already mentioned, waves passing through the denser gas are partially absorbed, even as they are refracted. In fact, the D region is not very good at refraction. In HF bands lower than 10 megahertz, so that would be 40, 80, the AM broadcast bands and the lower frequencies, the D region completely absorbs radio waves. So here is an example of what I'm talking about. Here's your station and your transmitter, and your takeoff angles, depending on how your antenna radiates, could have some going up, could have some going out like 45 degrees, at some at 50, 60, 30, whatever. But you've got these really cool low takeoff angles. See what you do with these low takeoff angles? Blam! Gets this really long shot, and that's how you hit Europe. Whoa, Tony! Thank you! Well, I'll manually do it for now, but we got to figure that out. What's going on? Hold on. Oh, it's not plugged in again. My kids, they like that they can turn the party light on, and they mess with it. They come in my office and mess with it. So, Tony says, thanks for being awesome. Got my technician in general because of you. That's awesome. Thank you so much for that. I appreciate the support. And I'm glad it helps. I'm glad this is helping people. So, okay. Lower frequency waves are the most susceptible to ionospheric absorption. Lower frequency, meaning 80 meters, 40 meters, right? Lower frequency. Good stuff. Okay, so skywave and ground wave propagation. We just need to cover this a little bit. So skywave is the concept of what this is doing here, basically. We're bouncing off the sky, and in some cases we can get a ground bounce. And you can get multiple bounces up and down, depending on what the material of the Earth is and how your ionosphere makeup is at that given time. If what I'm telling you sounds like this is a bit scattershot and a little haphazard, it is. It's totally haphazard and scattershot. Because that's how this whole system works, right? That's why I mentioned NVIS as being a fairly reliable method of using HF and being able to communicate. Because you're just you're trying to radiate all that RF vertically, and you get this big column of RF back down. However, when you start trying to do these long-distance comms, you're at the mercy of the ionosphere. You're at the mercy of how well that sun is ionizing that UV. You're at the mercy of someone listening on the other side. You're on the mercy that... just a ton of things, right? A ton of things all have to play. That's what makes radio fun. It makes radio challenging. That's why there's contests. That's why there's... all the awards for working all the states, for these long-distance communication, working all continents, that kind of stuff. All of this is part of that, and it all comes down to propagation. So, propagation, fairly science-y, but very, very fun science-y stuff. So make sure that you understand it, because it's going to tell you what to operate on and when in a given day, week, or whatever. So each reflection from the ionosphere is called a hop, and allows radio waves to be received hundreds or thousands of miles away. Signals received in this way are called skywave, and propagation via the ionosphere is called skip. So you're skipping over the ionosphere, right? Makes sense. The higher the region from which the reflection takes place, the longer the hop. Again, you're higher, you go up into the atmosphere. This is D. You know, the D reflection would just get you on the east coast of the United States. But if you can get up on that F layer, it can get you over to what looks like way inside Europe, and that's past Italy. Okay, hopefully this all makes somewhat logical sense. It is fairly straightforward, but there is, again, some sciencey stuff just to remember. And again, this is one of the smaller question pool chapters that you have to remember. So, yeah. Patrick Dickey sounds like a shortwave listener like myself. A lot of this is fairly well understood to shortwave listeners. Shortwave listeners have radios that are fairly broadband. They can receive really low frequencies and really high frequency radios. Oh, thank you, Ellie. Ellie is a new patron. I thank you for the support. It's Elaine. Sorry, Elaine. It's Elaine, right? Correct me if I'm wrong. That should be Elaine. My screen's pretty far away from me, and I guess my eyes are going bad on me. So, shortwave allows you to basically, using shortwave, experiencing shortwave, get you more comfortable in this kind of band switching understanding, which Muff and Luff is going to explain this a little bit better. Muff is maximum usable frequency, and Luff is lowest usable frequency. Cool. All right. So, here's a question. Waves reflected from the uppermost F2 layer can travel up to 2,500 miles before returning to the ground. Hop that use the E layer are shorter, up to 1,200, because of the lower reflected height. Again, I just covered this. The different layers going to yield a greater angle, longer, wider contacts. Pretty straightforward. The ocean. So this is important too. That's why people on the West Coast, lots of contacts to Japan, lots of contacts to Australia. People in Europe. And the East Coast, lots of contacts over the Atlantic. Why? The ocean's highly conductive saltwater is a partially good reflector of radio waves. Propagation between Europe and the United States, for example, requires up to 7 hops, depending on the location and time of day. Somebody asked a question. I'll pause for just a second. It's totally unrelated to what we're talking about. The Truth Telling Mofo asks, what would you recommend as a first HF mobile? I want to answer this in 2 parts. One, I did an entire live stream on this. If you go to the Ham Radio Crash Course and bring up the live stream playlist, I think it's like choosing a mobile radio or something like that, and you can see it's my big dorky face and I'm holding a box. So most people would recommend, or a lot of people would recommend the FT857D made by Yaesu. I don't. It's an older radio. It's woefully due for an upgrade, and that upgrade came in the form of, I believe it's the 891. Excuse me. Less gassy with this one. FT891, is that right? Am I right? Yes. The Yaesu FT891, I think, is a more superior, it's a better radio, and it has been compared to the ICOM 7300 in regards to its receive capability. Right now, it's $630 on Gigaparts. Not bad for a mobile radio that does 100 watts. No VHF, UHF, though. That may be a deal breaker for some people. For me, it's not. I don't have a problem having 2 separate radios in a car. So I'd rather have the best, as good a performance as I can get than a hodgepodge of performance on something like the 857, which I'm told not very good on VHF, UHF. Okay. Hopefully all this is in focus. If you're having any problems reading anything, let me know and I will adjust. Okay? All right. Short skip. All right, this is important too. Signals received via skywave at much shorter than maximum hop distance are called short skip. Short skip is also a good indicator that there is sufficient ionization to support longer skip distances on higher frequency bands. So, for example, short skip on 10-meter band is a good indication that skywave propagation may be available on the 6-meter band at low takeoff angles. So, you're using the atmosphere and understanding the atmosphere to figure out, hey, I'm on 10 right now, and I'm getting a short skip, meaning I'm further away, and this is important too, I'm further away than just being a direct contact. 2 stations that can just talk to each other, right? But long enough away that I require a skip off the ionosphere. So I'm getting picked up in Reno, and I'm in California, for example, on 10 meter. I'd be like, okay, that's pretty good. Why don't we try 6 meters? See if we can get that takeoff angle really low. It may be open. The band may be open. Truth-telling mofo, thank you. Oh, appreciate it. That was for answering his question. Thank you so much. Yeah, look into the 891. I think you'll be pleasantly surprised. There's a really good article that I think I covered on the stream, and I mentioned it before, that really sings its praises of being a very useful receiving radio. So, yeah. Okay. So you're starting to think about your radio of, well, I'm just going to do 20 today. Well, yeah, maybe not. Maybe you're going to do what the best propagation is on. Which band has the best propagation at the time of day that you're utilizing it? And hopefully you'll be able to start, maybe research it a little more. Maybe you'll be able to start using lots of free websites that show you propagation maps and figure out how, what might work the best. Okay. So, let's see. This... Receiving signals, multipath, ground wave. Okay, ground wave signals travel along the surface of the Earth between stations. Rock and soil and concrete are not very good conductors, and so a ground wave signal loses strength much more rapidly than if it were traveling through the air, of course. The high frequency of the wave, the greater the loss as it travels. Ground wave propagation on 40 meters, for example, may be up to 100 miles, but on 10 meters, only a few miles at best. Makes sense. Ground wave, you're passing the RF along the ground. This is that direct comm type stuff I was talking about. 1-to-1, no skip, right? Whisper, somebody just yelled out Whisper, WSPR. Whisper's a digital mode. It's kind of like a reverse beacon, and it allows you to push out your packet or your digital packet, and people will post on the internet where you were heard. It's a really easy way to see how the live propagation is for your station. And if you jump around the bands, play around a bit, you can figure out, oh hey, I'm really good on 30 meters and I'm getting all the way to Australia. Like for me, I'm in a really good spot for 30 meters is very good to the west of me, to Japan and Australia and New Zealand in the evening. Anywhere from gray line, which we'll talk about in a second, till early morning. Very, very good there. Okay. All right. Long path, short path. So, got news to break to you. The Earth is round, and this is your location. If you are transmitting, there is a long path to the station you're trying to talk to, right? Just the shortest path. And then there's the short path, and then there's the long path, which goes around the other way, the long way. If propagation is extremely good, and it really likes talking about this in this book, propagation being good, even though we've got years before it gets good again, there's actually situations where you can hear the long path. You can hear yourself, and the receiving side can actually will hear you, right? They'll hear you and then you again. Fainter, quieter, and trailing behind because it had to go further, right? It's traveling almost at the speed of light or at the speed of light, but still the effect is a bit of a echo, if you will. That's long path and short path. So that's the long way around. Now, you can, and here's a question, occasionally propagation over both long path and short path will be supported. Unless the long and short paths are almost equal, there will be an echo as the more delayed station arrives at a fraction of a second later. Got it. Round the world propagation is supported, and you can hear your own signal coming all the way around to your location 1/7 of a second later. So you can actually hear yourself if the propagation is that good. It's crazy. Okay, so sunspots and the cycles and all that stuff, we've been talking about it for weeks, probably as many times as we've made one of these streams. We've talked about the sun because it's important, and now you kind of understand why. Hopefully you all understand why. In previous discussion, you'll learn that the ionosphere is dependent on solar UV to separate the electrons from their host atoms. Yep. The sun is also generating UV radiation even at night, and a lot of this variation has been shown to be caused by sunspots. 11-year period known as a sunspot cycle. So sunspots vary in this 11-year cycle. Every 11 years you get this change, and we'll just jump over and I'll show you now what it looks like. Yes, this is a really good This is a really good graph. This is us. We're right here. We're right here in this dip. Look at 1954. Look how much different it was. Look in 76 to 87, 87 to 98, 98 to 2009. Look at how we've just progressively got worse and worse and worse. That's where we're at. And that's a sun cycle thing. It's not like we can do better with our environment or change things. There's nothing you can change to affect this. This is the way the sun is functioning. So there's nothing you can do. However, this is interesting. As sun cycles go down, certain bands work better than others. As sun cycle is high, certain bands work better than others. Bands that work well when the sun cycle is low do not work as well when the sun cycle is high, and vice versa. So let's talk about that. So, let's see, where was it? Creating more intense... On the HF bands above 10 megahertz and even into the lower... Oh, this whole thing should have been highlighted. Sorry about that. At the same time, more sunspots are observed on the face of the sun, more UV is being generated. So more sunspots, more UV, more ionization of the atmosphere. This creates more ionization on the HF bands above 10 megahertz and even into the lower VHF range. So more ionization, you can get ionization all the way into the VHF, UHF if it's really intense. It's not very intense right now. At the peak of the sunspot cycle, there may be sufficient solar UV to cause higher frequency bands, such as 10 meters, to stay open for long-distance contacts at night. Wow. That's not the case usually. We usually can't use 10 at night. Conversely, at the bottom of the sunspot cycle, when solar activity is low, the lower HF bands have good propagation, and the higher HF bands, above 20, are often closed. One band that seems to do well at all times in the sunspot cycle is 20 meters, 14 megahertz, which is pretty live right now. So if you are on 14 megahertz, make sure you're listening to that too, or listen to that after we're done with the stream. All right. So the sunspots also seem to move across the sun's surface because the sun rotates once every 28 days. That's why propagation conditions, good and bad, on the HF bands often repeat themselves. In a 28-day cycle, sunspots rotate back into view from the Earth. There's a woman, her name's called Tabitha Scove. She, you can search her on Twitter. She produces a weather report for the sun, and she does a really good job. She's got she's a part of the Ham Radio News podcast. Oh, I can't remember what it's called. She does a really good job. You should follow her on Twitter. There are multiple websites that will tell you the condition of the sun. It should tell you what's open, what's closed, all that stuff. We're going to talk a little bit about that. Here's a really good reference table. So 160, 80, and 60 meters in the day, 100 to 100 or to 200 miles. That's their limit as far as effectivity, useful effectivity. Nighttime, local to long distance with DX best near sunset or sunrise at one or both ends of the contact. So 80 is considered kind of a Ham Nation. It's on Ham Nation. It's also a part of something else, but yeah. 80 is a rag chew band. A lot of local people on 80, but it can open up for DX on the gray line. And gray line is sunset and sunrise. If one or both of the stations that want to work each other are at or before or after sunset, that helps them receive the signal. Think of it as kind of like a wave in the ocean, and water collects, but that water's RF. That RF is collecting at the gray line, and it's hitting the stations in the area, in that area, that kind of collects it up, and then you have better reception capability. I've always found gray line to be an amazing time to work on all kinds of different bands. Try it out. It's a lot of fun. 40 and 30, local and regional, up to 300 and 400. Short range at night, short range 20 to 30 miles, and medium distances 150 miles to worldwide. So 40 can be pretty interesting in nighttime. It can open up really wide, or it can be totally shut down and virtually silent, like no noise, no nothing, really quiet. 20 and 17. So during the day, 20 is the preferred band for SOTA, and we can go cross-country with that. No problem. Regional to long distance, opening at the near sunrise and closing at night. 20 meters is often open to the west at night and may be open 24 hours a day. That is true. I have found that to be true. And then 15, 12, and 10. During the day, primarily long distance, 1,000 miles and more, opening to the east after sunrise and to the west in the afternoon. Nighttime, 10 meters is often used for local communications 24 hours a day, locally at night. Now, 10 meters is really, really good for long-distance communications, assuming it's supported by the ionosphere. And that's the situation we're in, going back to this guy. Pretty low. So 10 meters is not too hot right now. Not to say it's not possible, and you should always listen on 10 meters. If you're going to be active on field day, make sure you check 10 meters throughout the day, because it can open up and close and open and close. All in the case of a 24-hour period. Okay, so I'm not going to get a lot into how you measure solar activity, because that's going down the science-y rabbit hole that I frankly don't understand that well. I'm just going to say that. I'm just going to say that up front. What we will talk about is assessing propagation, and we'll answer some, and we'll hit some of these questions really quick too, just to make sure that we've nailed them. You know what? We can hit this when we do the practice. We'll go straight into the practice after this. Okay, assessing propagation. Somebody asked what the MUF is. I already mentioned maximum usable frequency, and the LUF, lowest usable frequency. So, given the solar activity indices and a reasonably good model of the Earth's geomagnetic field, scientists and communication engineers have developed fairly effective software tools for predicting propagation. These are all pretty much free on the internet, too. Amateurs make extensive use of these programs, and a general class ham operating on HF, you'll want to give them a try. So, the two key terms used in prediction programs are of particular importance, MUF and LUF, which we mentioned. Both the MUF and LUF depend on the specific path between 2 points. So you got to know who you're trying to talk to. Their location and distance apart. MUF and LUF also vary with time of day, season, and the amount of solar radiation and ionospheric stability, which we've been talking about. This is all kind of random chance. The MUF represents the highest frequency at which propagation exists between the 2 points. Waves at or below the MUF will be refracted back towards Earth. MUF accounts for propagation at all points along the path between the 2 stations. The MUF will be different on every path between your station and any other station. It must account for variations in the ionosphere at every likely reflection of the wave hops. So, I'll show you a map. In fact, I think I have one open. I'll pull one up if we don't in a little bit. The waves above the MUF will, at some point in the journey, penetrate the ionosphere and be lost to space. MUF must also take into account the likely takeoff angles from your antenna system. Again, factoring it all in, since this affects the ability of the ionosphere to reflect your signal. The LUF specifies the lowest frequency for which propagation exists between the 2 points. Waves below the LUF will be completely absorbed by the ionosphere. To make a contact with a distant station, you will have to use a frequency between the LUF and the MUF. There it is. So, maximum usable frequency, lowest usable frequency. If you're in there, in between 2 locations, if you're using the appropriate frequency, one at either below the maximum or above the low, you potentially get your signal out. I think I'm getting a bunch of messages on APRS. Hold on. We'll check those in a second. I just got just one. KA4 boy. Hi. Laugh out loud. What's up? I got that message. It's working. Let's throw this one out there. Throw a link out there to you guys. ncdxf.org. And they transmit continuously information on MUF and LUF. And then reversebeacon.net. That's very interesting. That's a very cool. For those that are on HF, I would check that out. Okay. So let's talk about solar disturbances really quick, because I think that's almost it. Solar disturbances. Solar flares. We've heard of solar flares before. A large eruption of energy and solar material when magnetic field disruptions occur on the surface of the sun. Coronal hole. A weak area of the sun's corona, the outer layer, through which plasma, ionized gas, and charged particles escapes the sun's magnetic field and streams away into space. Coronal mass ejection. An ejection of mass amounts of material from the corona. A CMA may direct material in a relatively narrow stream or a wide spray. So these can all affect it in different ways, our ionosphere. And most of them are not totally helpful. With that said, because again, remember, we're talking about sunspots. Sunspots increase UV. UV increasing is generally good for the ionosphere. However, flares, holes, and mass ejections are not necessarily what we want to see. UV and X-ray radiation from the solar flare travels at the speed of light to impact the ionosphere about 8 minutes later. Okay, that was a question. Okay, solar flare radiation comes and messes with all your ionospheres. There you go. Makes sense. And no, sun continually gives off-stream parts, solar wind, etc. Okay, scatter. Let's talk about scatter. All right. So this is important for, as you've experienced on VHF, radio waves often propagate by reflections from terrestrial objects and disturbances in the atmosphere. The same is true for HF radio waves and larger scale. In particular, the ionosphere is not nearly so neatly organized into horizontal layers or regions as we imagine. There are regions that are tilted at significant angles and reflect waves somewhat horizontally. So we'll show you. Let me see if I still got that bad boy up. Near real time. This is it. Let me show you the hodgepodge of this right now. So this is a real-time propagation map. These circles that look like topographic kind of layers, that is the effects on the ionosphere. So depending on where your location is and your target location, you find the middle point, and wherever you lie in those striations, those band striations, you can follow it to the side of the map and it will tell you in megahertz what the most optimal number of what frequency you should be in, what band, right? That's pretty complicated though. There's a lot going on. And that like wave looking thing in the middle, that's the gray line. Okay? This is spacew.com www/realtime.php. I'll post that in the chat. There you go. Cool. So you guys can check that out. Good stuff. Little nerdy. But anyway, so because of what you just saw, there's all this funkiness, all these lines, all these striations. Sometimes signal can just kind of break off, right? Just fall off the end. This is a scatter. This is the effect of scatter. And it could be from different layers of the, you notice how there's some off of E, F1. This is during the day, obviously, because there's F1, F2. And so you can get picked up along the way to who you're trying to be received by. And they, in themselves, can also be in the middle here and receive the other returning stations because of how the propagation works and what frequencies you're on for that given mode. So it's important to know. Scatter signals received via HF scatter are usually weaker than those received by normal skywave propagation because the reflection is not very efficient and tends to spread out. Because it wasn't really the goal, right? Your goal was to get your takeoff angle to match the right point on the ionosphere and then get to your target. Now, somewhere along the way, it might break off because of the complexities of the atmosphere and get kicked down. That's scatter. Okay. This is just ground bounce. Oh, did it? That's interesting. Oh, that's cool. Okay. NVIS. We talked about NVIS on antennas and how NVIS is really important for emergency comms. We're going to state NVIS again. You'll recall that for waves below the critical frequency, the ionosphere reflects waves arriving at any angle, even vertical. At most locations, the critical frequency is always above 5 megahertz, and frequency rises above the 40-meter band. For the signal below the critical frequency, when it's radiated vertically, the reflection scatters the signal back to Earth over a wide area around the transmitter. Communication using this special scatter mode is called near vertical incidence skywave, NVIS. And that's what it looks like. So you're going almost straight up. So this is your station. There's a little antenna there. And you're getting a bounce off the F1, and you're getting another bounce depending on the angle at which your RF is coming out of the antenna, all the way out to what looks like 25, 50-something kilometers of propagation space. So almost vertical, near vertical, because if it's like a vertical antenna, there's a null at the center point, so you're kind of getting, this. So it's going out, bouncing back, and you're getting some bounces. And wider areas of angles will get you further out. Okay? And that's it. Gosh, we're going to have to get into safety soon. We're going to have to start talking how to be safe with radio. Heaven forbid. That's probably what's going to be next. But that won't be for a little while, because next week is going to be our fun Q&A. And the following week, I think, is patron pick. So if you're interested in becoming a patron and get involved with patrons picks are the topic of the first month stream. I always let the patrons pick, or have been doing it now twice. I let them pick what they want to talk about. It's been a lot of fun. Surprising, so last week was APRS on the cell phone. Sorry, 2 weeks ago was APRS on the cell phone using a Baofeng. That was great. That was really useful. I had really fun putting that together. So lots of fun with that as well. If you're interested, go check out the link in the description. Okay, radio wave, we are on, let's see. We're using the ARRL General Class app. Okay. And we're going to go to radio wave propagation, which I think was, is that how they did this? Is that how they titled it? Ooh, we're plowing through this book, guys. G3. Hit! You sunk my battleship. All right, we've got 3 sections here. They're pretty straightforward and easy. Okay. At any time you think you know the answer for this, yell it out, but I'll talk to some of it as long as I know it. What is the significance of the sunspot number with regards to HF propagation? Higher sunspot numbers generally indicates a greater probability of good propagation at higher frequencies. Lower sunspot numbers generally indicate greater probability of sporadic E. A 0 sunspot number indicates radio propagation is not possible on any band, and all of these choices are correct. Ow! So, lower sunspot numbers generally indicate greater probability of sporadic E propagation. So I'm always warning you, be careful about all of these choices are correct, because they're often not. And it's a trick. They want you to select D. So I immediately said, okay, it's A. But then C's possible. A 0, not even possible. But I don't think that's true because of VHF, UHF. And then B, lower sunspot numbers generally indicate greater probability. I don't think that's true. So I could just guess, but I'm going to wait for a... I'm going to phone the audience here, poll the audience, and I'll get 3 more answers. If somebody wants to volunteer, 3 more people pick an answer, and then we'll pick the average, and we'll go with that. It's Swift says A. Patrick Dickey says C. Travis, not answering the question, says, wow, I'm hearing New Zealand tonight. Not able to reach him, though. Yeah. Such is the way of HF radio. You're likely going to hear more than you can transmit to. And that could be in part to your antenna. And it could be in part to how much power you're putting out. Okay, we got 3. 2 for A, 1 for C. Let's go A. Oh, it was A. So some of those are kind of tricky because you think 0 sunspot number indicates no radio propagation is not possible on any band. That can't be true. So all of these choices are correct, would not work. What effects does sudden ionospheric disturbance have on the daytime ionospheric propagation of HF waves? Okay, so sudden ionospheric disturbance. We talked about that at the end. That's your coronal mass ejection, your solar flares, etc. It disrupts communication via satellite more than direct communications. It disrupts signals on lower frequencies more than those on higher frequencies. None, because only areas of the night side. We know that's not true. Hey, Zorro, what's up? Hey, buddy. Zorro and I are going to do a live stream at 10 p.m. tonight talking about the state of California gun rights and whatnot. So if you're interested in that, go to gunchannels.com and look for the post. I think it's going to be 10 p.m. California time, so that could be late for some people, but anyway. It disrupts. So I'm getting Franklin says B. It disrupts signals on lower frequencies more than it does on higher frequencies. I think that's true. I think that's just a general true statement. Yep, it is. Because of reasons we already covered. VHF UHF says, I don't care. I'll blast through your ionosphere. I got places to be in space. Oh, somebody said fix your iPad time. I don't know what the deal is with my iPad time. Yeah. Sorry about that. Don't be confused by the time on my iPad. Approximately how long does it take increased ultraviolet X-ray radiation from solar flares to affect radio propagation on Earth? It's 8 minutes. 8 minutes. Everything takes 8 minutes from the sun. The sun is 8 minutes away via the speed of light. Via the speed of the sun. Which of the following are least reliable for long-distance communications during periods of low solar activity? It's D is the answer. Low solar activity. Okay, we talked about that. Low solar activity supports 80 and 160, the low frequency bands. Low activity, low frequency. Low frequency, low activity. Just keep that in mind. Easy to remember. What is the solar flux index? A measure of the highest frequency that is useful for ionospheric propagation between 2 points. No, that's MUF. A count of sunspots, which is adjusted for solar emissions. That's probably it. Another name for the American sunspot number, a measure of solar radiation at the 10.7 centimeters wavelength. No. Oh my God, is it sunspot number? Oh, whoa. Okay. I got that one totally wrong. So it is a measure of solar radiation at 10.7 centimeters wavelength. So don't forget that. Just got to remember that one. You can't logic your way into that one, except it's not A. We know that because we know that's MUF. Hilarious. Sorry about that. What is a geomagnetic storm? A sudden drop in solar flux index, a thunderstorm which affects radio propagation, ripples in the ionosphere, a temporary disturbance in the Earth's magnetosphere. Oh, somebody's talking about the fan on their radio. I was like, man, okay. I had to catch up on that one. We do have a few gun rights left in California. Just a few, though. Not a lot. See, this is one of those questions we didn't read in the book because I don't understand this stuff well enough. So what is it? What is a geomagnetic storm? Is it a temporary disturbance in the Earth's magnetosphere? I think it is. It is. That's an easy one to kind of suss out. How many questions are in this? Oh, 16, man. At what point in the solar cycle does the 20-meter band usually support worldwide propagation during the daylight hours? At any point. Right? Only at the minimum point, only at the maximum point, at any point. I think it's maximum. Any point is possible. It's going to be either B or D. D. Yeah, it's D. Okay, so put that one to memory as well. I would figure that 20 would be helped by maximum point regardless of anything. It would just be assisted by it. So there you go. Use 20 for everything during the daylight hours. It's good at night too. Not as good as daylight though. Which of the following effects can a geomagnetic storm have on radio propagation? Improved high latitude HF propagation, degraded high latitude HF propagation. 20 is the magic frequency, Patrick says. That is correct. Degraded high latitude HF propagation, improved ground wave propagation, improved chances of UHF ducting. I will defer to the chat for this one because of the geomagnetic storm stuff. I don't remember. I just don't know it that well. I don't want to lie to you guys. E. Yeah, it's definitely E. Go E. Always go E. When all else fails, go E. Geomagnetic storm. Degraded high latitude HF. Sure. It wouldn't be improved. Oh, everything's improved. Yeah, it's B. So that's a cheater one. All the options, I wasn't even reading. All the options are improved. I saw geomagnetic storm went, Rrr. So everything says improved. The only one says degraded. That's the answer. That's pretty easy. All right. So that's an easy test-taking one right there. What effect does a high sunspot number have on radio communications? High-frequency radio signals become weak. No. Frequencies above 300 megahertz become usable for long-distance communications. Long-distance communication in the upper HF and lower VHF range is enhanced. Microwave communications becomes unstable. C. So high sunspot number means you're getting more UV, which means you're getting more ionization, which means the upper, the higher frequency HF and VHF range is enhanced. Enhance. What causes HF propagation conditions to vary periodically in the 28-day cycle? The rotation of the sun on its axis. Yeah, buddy. Just remember, 28-day cycle usually means rotation of something. Approximately how long is the typical sunspot cycle? We talked about it. It's 11 years. As we pause to go to the next question, make sure you've hit the thumbs up for those that are new to the stream or came in a little bit late. I would appreciate it. What does the K index indicate? I like people are getting active in the answers there. I appreciate it, guys. Keep it going. What does the K index indicate? A relative position of sunspots on the surface of the sun, the short-term stability of the Earth's magnetic field, the stability of the sun's magnetic field, the solar radio flux at Boulder, Colorado. I don't know the answer to this. K index. It's got to be the Earth's magnetic field, right? Patrick says D. Patrick says D, but that might have been to the previous question. What was the previous question? Was it D? Yeah, it was D, so probably not that. It's B, somebody says, the tinkering corner. Short-term stability of the Earth. It probably is because that's the stuff I don't really... Yeah, there you go. The K index is the short-term stability of the Earth's magnetic field. Good work. What does the A index indicate? Of course. The relative portion of sunspots on the surface of the sun, the amount of polarization in the sun's... Timeout, I need another beer. Okay, we'll all wait for you. The amount of polarization of the sun's electric field, the long-term stability of the Earth's geomagnetic field, and the solar radio flux at Boulder, Colorado. Is that the same answers? Let's see what was the difference. Oh, slightly changed. The long-term stability of the Earth. Yeah. So If the K index is the short-term Earth's geomagnetic, this is the long-term stability of the Earth's magnetic. So keep that in mind. Don't confuse K and A, and they're tricky with the question, so be careful. How are radio communications usually affected by the charged particles that reach the Earth from solar coronal holes? HF communications are disturbed. Got some kind of action going on my phone. VHF, UHF ducting is improved. Okay, time in. You didn't miss much. VHF, UHF ducting is disturbed. So everything should be disturbed is the option, but I'm pretty sure it's HF. Disturbed. Got it. Everything's disturbed except VHF, UHF. VHF, UHF don't care. How long does it take charged particles from coronal mass ejections to affect radio propagations on the Earth? How long? How long? 4 to 8 minutes. Oh, no! Wait. Okay, let me read this because I screwed it up. How long does it take charged particles from coronal mass ejections to affect radio propagation on the Earth? It can't be days. It's got to be hours, right? Yeah. Okay. So 4 is too fast because that's faster than the speed of light. So I should have known better. 20 to 40 hours is better because it's not days, right? So. Okay. All right. What is the... Oh, this is the last one. Cool. And we can get to fun stuff, talk about ham shacks, and answer some questions. What is a possible benefit to radio communications resulting from periods of high geomagnetic activity? Auroras can reflect VHF signals. I don't think that's true. Higher signal strength for HF signals passing through the polar regions. Improved HF long path propagation. Reduced long delayed echoes. Yeah. Wicked Perfect covered it exactly on that last question. Particles aren't going light speed. They're slow. Okay. Travis just said, I just made a contact to New Zealand 14,000 miles away. Travis, post what frequency and what mode you're using. Wait, auroras can reflect VHF signals? See, I didn't even know that. Let's go with that one. Wow, I would have got that way wrong. I didn't even know that. I just take pictures of auroras. And that's the last question, so good. That's probably for the best. Remember, geomagnetic screws with everything. Indeed. Again, I'm using the ARRL General app for taking these tests. So, have at that. All right. I will take your questions now if you have them while I work through the ham radio crash course. So again, ham radio crash course, we have a thing called HRCC Shacks, hashtag HRCC Shacks. And so if you tag something HRCC Shacks, I will talk about it in the live stream. And I'll make fun of your radios for you for free. All right, what do we got? David, he posted his shack, which is in front of a computer. It's a Baofeng UV5R, looks like, and a Baofeng lapel mic. And he says he's got a 771, geez, antenna on the way. Very good. Can't make fun of you. That's a Baofeng. This one, I saw this earlier today. Very nice. Got a man in a hammock with a BF F8 HP there and a Nagoya. Very nice. I love to... lay in hammocks. I was thinking I'm going to set up my hammock for field day. And I'm just going to rock that thing if I need to take a nap. Justin has a good one. Justin is, I think he was out he was riding around his truck, had some time, got out his chair and his Baofeng and a beverage and a notepad and sat down and started playing radio. Very cool. I like that one a lot. And I think this is the last one that's new. Little corner of the world here's got a CB. Looks like, I can't tell what that is, the top one. I gotta zoom in on this bad boy. I mean, it looks like a rotator, but it's not a rotator. Oh, I can't zoom in. 2 bow fangs. Looks like a CB, and then below that... Oh, it's an SWR meter, I think. That's a big SWR meter. It's classic. And then below that, that's that crazy 25-watt mobile that everybody loves. Everybody loves that thing. Okay, cool. Did I cover this one? We'll do this one again because it was really good. Got kind of RV portable. Got a Zaiju, and a Baofeng, looks like an 82, with a tablet and also a Windows laptop running FT8. And there's his vertical antenna. Very cool. Very cool. Oh, cool. Carrie posted something on the Reddit. Let's, where is the Reddit? I had it on this page or another page. No, we'll do it live. That's not what I want. I want HRCC. So yeah, all you need is reddit.com/r/HRCC. Oh, cool. Carrie posted a very nice... Okay, she gets extra points for having a can of LaCroix. We love LaCroix in this house. Very cool. Is that a Surface? Is that a Surface Pro? Oh, she's watching the stream, it looks like. Awesome. Watching the stream. She's got the book, and she's... Okay, well, there's extra credit. Carrie's kind of being teacher's pet here. I don't know what to tell you guys. I'm gonna end up with a bag of apples on my front porch, I think, pretty soon here. I'm just kidding, Carrie. Very nice. Very good. What else we got going on? Oh, cool. Hey, by the way, if you're interested, the newsletter for June went out in the open. So if you want to grab that, go to Patreon and check it out. If you didn't see it, it's for Field Day, so it still could be useful. We do have a week. I wasn't kidding when I talked about that in the poll that I posted. I'm curious what people are doing. I was half joking. If you actually are doing something pretty interesting, post in Facebook. Post anywhere that we have the Hammer Radio Crash Course, whether it's Discord, Reddit, Discord, I think I said Discord, Reddit, all over. Post what you're doing. Get people excited, and yeah, that's. Field Day is important. Field Day is important for a number of reasons. One, to get better at being proficient in emergency comms, and also to have a lot of fun with radio. So, Sandman, want to say thanks. I took my technician exam this past Wednesday and got 1 wrong. Also took the general and got 19 right without any studying, but I'm in no hurry to get it. Right on. So I will, this is just my personal opinion. I think it's best if you get your technician and try to get your general as fast as possible. And then you can pump the brakes on extra. This is the United States. This is not anywhere else. I know that there are people in other countries with other license problems, but here's my problem, is technician, and we talked about this before in that whole license enhancement that they want to do for technician. Technician is a VHF, UHF access. It's just for VHF, UHF, really. 10 meters is great, but it's not great right now. It's not great right now in this 11-year down cycle that we just talked about for propagation. So you don't get any benefit on HF for being a tech. You really should get your general. And I'm doing this series because I want people to get their general at least. That's my biggest goal, is that you watching this, any of you watching this, and I should say this more often, my goal really is to get you guys your technician and your general. If you want to move on to extra, so be it. And of course, I want you to get it if you're passionate about it. I don't want you to get it if you're not passionate about it. But getting you to general is where I want you to be, because then you get the most fun with radio, I think. You get the most access, you get the best of HF and the best of VHF, and you can do just about anything you want. Only thing extra gives you is more access to larger frequency spaces, which is nice, but you don't need it. Okay, so general's the way to go. OB George, came across your channel randomly last Thursday night, knew nothing about amateur radio, but saw there was walk-in test 2 days later on Saturday. So I took a bunch of tech practice tests and passed. Wow, very good. Very, very good. That's awesome. Obi George, make sure to check out Ham Radio Crash Course on Facebook or the HRCC Ham Radio Crash Course on the Reddits. We were all over the place. Yeah, you got a bit of time before the questions change on general. But do it. Do it. Do it. You know. All right, I'll take questions. Otherwise, I'm going to hop out of here, and we're going to go hang out in Discord for a while for anybody that's interested. And I think Zach posted the Discord. Let me go back here. Make sure you grab that. All right. Cool. I think I got all the questions. All right. So without further ado, then, we're going to wrap this up for tonight. Hopefully that made sense. I enjoy propagation. It's very sciencey, very heady, but very important to the radio, the use of radio. So hopefully that was enjoyable. Guys, again, thank you for the thumbs up. Post your comments below if you haven't already. If you're just finding this, which if you are, that's awesome. Make sure you hit subscribe. Click the little ding-a-ling bell to tell you when I post. I had food poisoning really bad. Well, mild case of food poisoning, but still took me off my feet for 2 days. On Monday and Tuesday and part of Wednesday this week. So I didn't post any of the videos that I needed to do. I didn't make any of the videos I needed to do to get ready for field day. So get ready for a bunch of stuff hopefully soon. I've got to talk about my solar panel. I got to talk about my remote powering. I got a lot to talk about. And it's going to be a lot of fun. I'm both nervous, anxious, and excited for field day. And I should do this before we go. I want to make sure I'm not missing any APRS messages. So let's check that really fast before we go. Okay. So... Oh, no, it was K4 Boy was the last one. And he said, hi, laugh out loud. Cool. All right, so APRS is working there too. Awesome. All right, so that'll do it. We'll see you over in Discord. Take it easy. Oh, question. What is the winning lotto numbers for tomorrow? Man, I wish. You know how much, like, I don't even want to talk about it. All right, guys, that'll do it. Take it easy. See ya. Or maybe. Maybe that'll do it because I didn't have the stop stream button up. Okay, now we're done. Later.